This session is going to be the top 4 ways to build machine learning prediction for the mobile and IoT. As you remember, the last session we talked about machine learning on the mobile, and we talk about is the prediction piece. So we'll talk about, now this is going to be a little confusing because when we talk about edge, everything's on the edge on the device. But when we talk about these 4 pieces, we'll mix and match a little bit. So we'll be calling APIs, we'll be using the model on a device, we'll be training a model in the cloud to show you kind of the differences. So as we go through, let me know. I'm going to do a few demos to kind of showcase how that works and the value of both having it on the edge and then the value of just simply calling an API call. So smart applications generate and receive rich data about environment. They can extract relevant from huge amount of data in real time and take action. So this is that prediction model. So we're talking about training that model, bringing it onto the device, and then inference or prediction of that object or image or text or voice that's sent to that model, and the model says, okay, I believe that's 80, 90% accurate, that it's this voice, this person, this face. So that's the concept across the board for all of these managed machine learning services or on the edge when we have the model on the device itself. So we talked about this earlier, right? The benefits of machine learning on the edge, and we're talking this is the time where we have the model on the device completely offline. Latency, we talked about when we opened that app and you could see that it was doing real-time object detection and it was scanning through real-time and sending information from the camera directly to that that model. That model was a 100 meg file, so it was a big one, trained on thousands of different categories. And then so there's no bandwidth required. It's not sending any data. It's always available. And then privacy, depending on what you're sending. If you're just scanning pictures of regular everyday stuff, but imagine use cases where maybe you're taking sensitive data or skin lesions and you're a dermatologist and you want to identify certain skin cancers. You know, you want to keep that information private if you can and keep it on the device so that it's not sending information in the cloud. You can still securely send it to the cloud if you want, but the idea is keeping everything local, real time as you're scanning and taking pictures of that patient. It could give you those predictions based on the information. If you say you're in a clinic and it doesn't have good connectivity, you have that information available to you on that device. So some of the deep learning challenges. Again, resource constraint devices, CPU, memory, storage, power consumption, all of this. As I was running this demo through the device and we were just scanning across, it's probably using a lot of compute power, a lot of memory. So you want to make sure that's like one of the only apps you have open and you want to scan, but that's a specific use case. And it depends on how much information you want to send back to that model. And again, there's certain cases where you could send everything to it and as fast as possible you can take it, or maybe as you're scanning the room or taking a picture, you can just do it every few seconds, or simply take a picture and then send it to the model, and it's a little slower process. But it depends on how real time you want to have it. You can control that. Network connectivity, availability, cost, bandwidth, latency. On-device prediction may be the only option. So there's a lot of times where we're talking about other parts of the world, traveling with airplane mode, or you're in the subway or plane, wherever you are, and you just have no connectivity for these devices, or some of the older devices that just are at home. iPads in the home may not be on Wi-Fi for some reason. So you could do the on-device prediction, may be the only option. Deployment. We talked about that 100 meg model. You don't want to be deploying that to the App Store all the time or reloading the customer's app all the time. So updating code and models in mobile apps or fleets of devices is not easy. So this is a lot of the cloud providers are coming up with solutions for, and in case the Apple we talked about with CreateML, they're able to take this 100 meg model and cut it down by 70% in some cases. So they're making some great strides on making sure that these models are smaller size for a mobile device, but yet still accurate. So that's the big deal. So it depends on how accurate you want to have it and then what you want to put on the device, and that'll determine whether you store that model in the cloud and then make API calls to it. So we'll talk about that and making predictions on mobile or API based on the size of the model, what type of information you want to get back. All those kind of variables come into play. So prediction inference on mobile. So number one, we can call application services. So now we're talking about using an API and calling a managed service like Rekognition. So Rekognition is a good example. I'll do a quick demo. Rekognition is the service where you can do video or images, and then it gives you back information, standard tags like a desk, or does celebrity recognition. It does identifies nude photos, and then you can set up that prediction level if you want. But you have to be connected, and you take a picture, you send a video to Rekognition, and then Rekognition sends that information back. And let's do a quick demo just to demonstrate that. I'm going to connect in my phone so you can see it. So we just created this. Part of the Rekognition has a celebrity detection, as I talked about, and we're going to release this blog here shortly. Let me pull up QuickTime real quick. So they have a celebrity identifier as part of their service. So instead of tagging and all that, they allow you to send pictures or images, via the API, and then it'll tell you if it's a celebrity or not. And that's what we added to our device. So this is an example of calling an application a managed machine learning service simply by taking a picture and sending it to Rekognition. And Rekognition goes to their model and then sends it back and says yes or no, and then the name of that person. So let me see. I'm going to do QuickTime real quick. I'll keep this up so I don't have to keep setting it up. Somebody might have already seen a sneak peek of this, but okay. So in the celebrity app, what's not celebrity app? Is that it? Cancel. So in the celebrity app, all it does is allows us to choose a picture from our photo album or take a picture of someone live. So if there was a celebrity in here, I could take a snapshot of that person, and then it'll automatically send it to Rekognition and tell me whether that's a celebrity or not. But I don't have any celebrities in the house, and or do I? Do I? Yeah. Well, just for the fun of it, we'll show you. Okay. So I'm going to take a picture of the crowd. I hope you guys are okay with this. I'm going to use the photo. And then behind the scenes, it's not where we don't see much going on. But if anybody was a celebrity that Rekognition identifies as a celebrity, we would see, there's a name over there. So somebody's been identified. And then if I click on the name, it'll go to IMDb with that celebrity. So the nice thing is about this, if it doesn't identify you, it may identify your celebrity lookalike, which is kind of fun, right? And the use cases for this are kind of narrow, but the idea is from mobile device, we're taking pictures, and we could constantly call these services if we wanted to. But this is a good example of not real time where we have to take a picture where, we talk about Rodeo Drive and I want to take pictures. So let's do a real test on this with multiple images. So this is just a website, and hopefully with the computer screen it doesn't do too well, but I'll take a picture of these celebrities, okay? And then can you guys still see the screen? Oh no, you can't. QuickTime. Okay, so I just took a picture of the celebrities on the screen, and then I'm going to say use photo. And so now it's going back into Rekognition and identifying each of these faces, and then it's going to scan through and try to provide, hopefully, with some accuracy, all the names. So in most cases, I think they're Angelina Jolie, Adele, Prince, Kardashian. Is that Chloe? Is that the right one? Not sure. But the nice thing there was we were able to create this app, and it just one simple API call was sending one image. And it said, okay, it's going to go identify those. So this wouldn't work for the Rodeo Drive thing, but if you wanted to identify something on the TV, anybody used X-Ray before with Amazon Prime Video? X-Ray is one of the services where it kind of goes around, and you'll see a little bar, and it'll have each of the actors and some details. And that's what it's doing is it's behind the scenes. It's already analyzed the video and pulled out a lot of information and then pulling out the IMDb. And if I clicked on one of these links like Khloe Kardashian, I hope I clicked on that, and then it'll take me to the IMDb page and give me profile information. So that's an example of using a managed application service or API. There's a lot of third-party, like we talked about, available out there on the internet. So this Rekognition is one of them. There's other APIs that you can simply call. You get an API key. you send an image and it'll tell you something about that. Now, what behind the scenes, this is using a model that Recognition has, and it's been trained on a number of celebrities. We don't have access to that model. But the idea is, if we were going to do this on the edge and be powerful, we would have our own images of celebrities or collect them online. I mean, we could go scrape the internet, right? Pull up thousands of images, train our own model, bring it on the device, and then we could do more real-time things, right? Where we wouldn't have to send the picture one at a time. I could go and walk across there and in real time, picture identify facial recognition. Remember, facial recognition's already on the device with the yellow square, right? So it'll go through and scan, and it'll automatically tell me those names in real time, and then I can click on it. So it kind of changes the use case a little bit, where I can click, send, okay, API call, great. Now I could do AR with this, and I could actually set up AR, which is augmented reality, and so in my camera, in an app, and then behind the scenes, it's actually analyzing, but it would be a little bit slower. So if it was like one image, so I could go through and scan, and it would be sending API calls behind the scenes, like every maybe 2-3 seconds, API call to Recognition. And then as I scan, all of a sudden it would pop up, give me a ding or a name on that person as I scan through as well. Yes, yeah. It was an Apple converted model. It was a standard ResNet model that's out there available for you to use in machine learning. Oh yeah. Oh yeah. So he's asking, can you do a live scan of these celebrity faces using the CoreML model from Apple? Yes, but that's a good point. So we won't see. So the difference is between objects. So the depends on what the model was trained on. This is a good example, right? Faces are completely different than desks. I mean, some people may look like a desk, but in most cases, not really. So that's a good question. So we'll run through that because we'll see this core vision. So now I'll face it toward. Can you guys see that? So bow tie. So this wasn't trained on faces or celebrities or anybody. So it's just using everyday objects. So maybe it'll pick up like a scene bow tie, brassiere, hairspray. Mm-hmm. The celebrity app? Yeah. So the celebrity app was this one where I took a picture of it. So yeah, imagine the same thing, and I can make it live when we're actually scan through. But then the difference there, right, because that was local to the device when I was doing all those objects. But here, if I had this model on the device, I could be able to go like this and take a picture. I wouldn't even have to take a picture. I could just go like this, and immediately all these names would come up, like instantly, which is kind of powerful, right? It depends on your use case again. Magic. No. Yeah, so I would just use the IMDb link so you could see in there. So IMDb has a link to all the profiles. So Recognition in response provides you a name. So in this case, Kardashian. So I was able to just do like a search for Kardashian in the IMDb, and then it pulls up that profile for that user. So that was the question: is how did we get IMDb to pull up that user? Yeah. Yeah, I don't have the AR VR demo, but the idea would be really similar to what we saw with this one, but it knows the actual location, because in response in AR we could put this text above the bounding box that's provided by Recognition or the other services or local. So we have a bounding box of the identifier, and it'd be the same thing where these texts would be over the bounding box of the person it identified. That's the difference, yeah. And so that's really powerful. As you go by, you can just kind of, imagine just a heads up. You're walking down the street, just like, boop, identify certain items. So it's kind of cool because you can see the differences between having the model on the device itself, the real-time aspect, and then if we want to just simply call an API, we can do that as well. Let me do another one quickly on that, because so we talked about some of these managed services. You can't see that there. So we got translate, and then we have transcribe and poly and comprehend, and I'll show you what that might look like here in the speech. We're going to build this. Yeah. secret. So the question was, with the recognition API for celebrities, how do we build that model? And that's the secret sauce. I don't know, you know, there's been people like, well, send me that model. I mean, the idea would be nice to send that model to us. The same thing when you send users to it. You could set up a user database with that as well. So we could take pictures of all of you. We could set up a profile in Recognition, and then we could send an API call to Recognition, and it should identify you. Yeah, and that should work with your names, right? That's the training. But the piece that's hidden from us is that model. We don't know how it's trained. Do we really care? I mean, not really. I mean, it'd be nice if I could say, well, can you just give me that model and then shrink it down so I could put it on my mobile device? Maybe that's the next step. That would be beautiful. That'd be perfect, right? Because then we have the best of both worlds. But then right now, you got to train that model and be specific. So we don't know what celebrities are in that list. We don't know where they got the celebrities. But we know it's a model, and it's built in, and then we just send an image, and it comes back. Yeah?
So what you could do in a way, you Google searches on celebrity names, and then scrape those images and those tags off, let's say, Google image.
Oh, absolutely, yeah.
Go ahead and run it. I mean,
Yeah.
I feel like a woman's way.
Oh, yeah. He's talking about web scraping. Yes, absolutely. I don't think Amazon did that, but that's possibly right. Yeah. And that goes for anything, like really. So when we're talking about building these models, you don't have to have the data. Maybe you could search through it. Like, you know, there's a machine learning application for parts for cars. You know this. Have you ever seen those schematics, like all the moving parts for a machine, for an engine? And imagine if you could take each individual picture and then be able to pull those from the internet and then actually do an image for like your Chevy, you know, 429, and then be able to go and scan your image and tell you exactly what part that is. And that's pretty powerful stuff. And again, you don't have to have all those images. You can just go scrape those from sites that you know that you might have legally. Okay, so back to application services. So this is another example of we're calling an API to do translation. And we're going to build this a little bit later, but I just want to show you because it's relevant to the application services. So we say, the quick brown fox jumped over the lazy dog. And then it translates the text. So we'll have audio back in there. But see how fast that was? There was no storage of models on the device. It simply said, I'm using the API. It translated my voice to text on the device using the Apple Speech API, and then it sent directly to Amazon Translate, translated the text of my choice, and brought it back fast. You notice, I mean, it was really like if you're walking down Amazon Translate, Microsoft, all of them have the translation services. But the idea is you're calling an application service from your device using machine learning, and you're just a simple API call. Yeah?
Can I take an existing model and train it with more data that's more relevant to my field?
Absolutely, yeah. Yeah, and that's the thing is with these application services, I'll go back to this. The great thing is about the application services is if they work for your use case, great. If you want to create a custom celebrity list, then that's when you want to create your own custom model. Of what? You do. If you train the model, that's yours. Yes, yeah. So you can't take any of these models because these aren't available as models. But you can take other models and then build on top of them. And what we didn't talk about earlier, but typically when you train a model in the cloud, you use transfer learning. And so transfer learning is you take one of those standard images that have been trained on regular everyday objects. You don't typically take a model and build it from scratch. You'll take a ResNet model or some other model that's been trained in the cloud and on regular everyday objects or faces. So certain model, depending on what objects you're going to want to customize, choose one of those models and then you learn on top of it because it's all been layered and tested and everything, and then you're going to build on top of that on those specific use cases. So you'll take that and then build that and test with your type of flowers or your type of images or glasses or skin lesions or whatever it might be. Yeah. Right, yeah. In my case, I was using, so the question was, I was using Translate for that last example. So yes, we don't have the models. That's what's nice about the managed service is you don't need to worry about it. And if it works for your use case, Translate, like it either translates. But now if you want it to translate in Hebrew or some other language that Translate doesn't support, then yes, you got to build your own model or wait till they support that language. Exactly, yeah. Yeah. Right. So the question was, can I extend that capability? No, you can't extend any of the managed service capabilities, right? So that's the issue. So when we go and use some of these application services like recognition and say we don't want celebrities or we want more objects to detect, then that's where you have to build your own model. And then you've totally wiped out the application services. So you're not using their model, you're not taking a starting model from them and building it out. You can't take the celebrity model, you can't take the speech translator model or anything else and translate, so you got to build your own. So that's kind of a tough one, because then it's like, it works great, like the tagging is awesome for recognition, but maybe recognition doesn't quite tag everything specifically, or you want to maybe train it and customize something on certain shirts or logos that it hasn't been trained on. You know, logo identification is a big one, right, for trademark infringement. So you could train a model, but recognition may not have all those trademarks, and for good reason. Maybe it can't trade and create a model for those logos. So in that case, you got to build your own model with all your own logos and data. So this is where data is very powerful, and if you have the data, then you can go create the models, and now, or scrape it if you need to, yeah. So does that make sense? So application services is just calling an API to transcribe, translate, and again, text to Poly. So we send that translated text to Poly, an API call. It's going to come back with an MP3 streaming file, and we play it back in our device. And quick, low latency, everything goes through, and it works great. And then Lex is a combination between Poly and speech. So it's kind of using the Lexa speech recognition. So I could talk into it as a chatbot, and then it translates my voice to a text, sends the text to Poly, and then Poly comes back and speaks that text to me in certain languages or in that voice that I choose. And I could choose various characters if I wanted to. So that's kind of nice because it's still using the application services. You don't have to have much of anything. And like the speech recognition piece, it's hard to build. It's like one of those things you want to build. We're going to take advantage of the Apple. We're going to take advantage of Lex. We'll take advantage of Alexa. And all Lex is taking that Alexa engine and allowing us as a mobile developer to put that same feature or functionality in our mobile device. Because I love that idea, because if you're anybody doing Alexa or built an Alexa skill, okay, and then have you figured out how to monetize from it if you want to monetize? It's, you know, there's ways to do it, but imagine taking that to a mobile environment. You know, like Kelly Blue Book, for example, we did a test with them, and you know they have their feature list of all the devices, all the vehicles, and now you can just talk into it and say, you know, what's my 2018 Honda Civic worth? And then it knows your location because you're on the device, and at the same time it may be displaying an ad for you. But if you're an Alexa doing the same thing, it's hard to monetize that. So as a mobile developer, we have kind of the advantage, right? We'll take advantage of the engine and then put it on the device. So now we're talking into it, and then we're also displaying an ad or showing an ad or whatever it might be. So we're taking advantage of all the speech stuff. And we don't have to create models for that because it doesn't really make sense in that case. Or in some cases, we don't want to call Lex, and we just use the speech API that's available from Android or Apple in this case. All that's been done for us, and we just take advantage of it. So does that make sense on cloud, on application services? That's one way to do machine learning. And again, if it doesn't work for you, then you can go and do the custom model. And you'll see that below here. Cafe and Apache, Python, those are all the frameworks that you can actually build a model from. And I'll talk about at the end the SageMaker piece where it kind of puts it together for you to build. Okay, number 2. Build and train in the cloud and then deploy the model to the device. So this is where we're going to talk about the edge, right? So we're going to bypass, we need a custom image, we need a custom feature. We're going to do our own celebrity recognition, our own employee recognition, whatever it is. So we want to use, for iOS, we use CoreML, remember, to access the local on-device train model, and then Android, we use TensorFlow Lit. I just forgot to change add E there. So this is the idea where we train in cloud. We're kind of ubiquitous here, but we could use CreateML. We could create it on our device, but typically you train the model on the cloud, which is using the supervised learning in this case, the common use case where send a bunch of images to the cloud, use one of those frameworks like TensorFlow, MXNet, trains the model, and then we convert that model to one of these frameworks and then put it on the device. And then that's the same thing we saw with those objects, right? So we go by and just do any of that. So that's the customization piece where you could have the machine learning on the edge, local, private, no network connectivity, and then you have it all safe there, and you're not making any API calls. So number 3, build and train in the cloud, but then host the model behind the API. You guys, any scenarios you might think about, it would be like if you have a really large data set, really large model, that 100 meg file. If you want it super accurate, like your app needed to be super accurate on this custom model, then in this case, you would build and train the model in the cloud, and then you can continuously train that model in the cloud, and then host it through an endpoint. So basically, imagine the model right here, and we were talking to it on the device, with TensorFlow or with CoreML, talking it to directly. So imagine we're taking that same model, and we're going to put it in the cloud, host it there, and we're going to front it with an API. Let's say an API gateway or SageMaker, whatever it is. Then we make API calls to that as if it was an application service. So does that all come together now? So before we call an application service with this model we don't know about or care about, now it's our own model that's fronted with an API. And the reason you'd want to do that is if you wanted the one nice model that you're continuously training, it's very large, and then your users don't need the real-time accuracy for that from the device. Or they have older devices. Let's say we have something in India, right, where we have 97% of the users are on Android, and those devices are 3+ years old typically. Then doing the machine learning on the edge may be not work for most of those users. So in that case, we would want to host this model in the cloud behind an API, and then have them call the API just like we did with the application service. Does that make sense? So these are just different options that you have. So in this case, talk about train a model in SageMaker or bring your own. You don't have to train in SageMaker. You just bring your own model and bring it in there, and they'll host it for you. And again, that's the piece where if at scale is another thing. Is if you want this model to scale, you would host it with SageMaker so that they could piece it out and then scale your requests to come in. So you have thousands or tens of thousands or hundreds of thousands of requests coming into that same model, and SageMaker can do that for you and spread out that load. And that's the other thing about the edge. The advantage of edge is the devices, the models on the device, so you're never worried about scale. So you could have 10 million users, 100 million, it doesn't matter. They're all calling the model on the device itself. Now, if you want to get the model on the device, then you'd have to update all those millions of devices. But that's another advantage to having the model on the devices. There's no API calls, and then you're not managing those users, and scalability is not an issue. Yeah. Yeah, that was the last one we talked about, where we talked deploy model to the device. Yeah, that's number 2. Number 1 was call application services. Number 2, deploy the model to the device itself. That's the edge. And then this one is, instead of deploying that model to the device, we're going to host it behind an API.
Well, edge deployment. So, certain model should run on certain set of structure, right? So, will there, can you really train model on your SageMaker and push it to iOS specific core? Because there's a different thing you need to manage. From my understanding, the ResNet, we run ScanN, RCN, all this stuff, they have different structure.
Yeah, so he's talking about different structures of models, and then when you put the model on the device itself, you have problems. Yeah, I mean, there's a few, but the idea is you still have this core model, right? And the format doesn't really make that much of a difference. I mean, there's tools available, and so it may be difficult to take an MXNet to CoreML or a TensorFlow to CoreML. There's tools to be able to convert that, but it's still the same data, it's still the same core data. So essentially, when you get it to the two devices, the different platforms, the results should be exactly the same. Should be the same as if you were to host it on SageMaker and make an API call from that device. Should have the same results across the board.
It sounds like, you can only deploy convertible models.
Yeah, the question is, you can only deploy models to the edge if they're convertible from the model that's been trained on. And yes, but most cases, I don't know, maybe 90% plus of the models that are trained in the cloud can be converted to the CoreML or TensorFlow Lite. Now, the biggest difference is a lot of them will be huge. Could be hundreds, could be gigabytes of data, which isn't practical for a mobile device. So that's when you choose these other options, where you call the application services, or if you really need to build your own, you host it behind an API. Yes.
Okay, so the second question is, you said, let's say I have this huge model that's always, I'm putting a lot of data in, it's gigabytes. Is there a way to compress that model and reduce the accuracy, make it smaller? Or do I have to retrain it from a smaller data set?
Yeah, let me just repeat the question real quick for online. So the first one was, we can build the model in SageMaker, convert it to CoreML or convert it to TensorFlow and put it on the device? Yes. Yeah, that's capable. There's a couple tools involved with it. You extract that model, and then if you use MXNet, you extract it as an MXNet format, and then you convert it using a scripting, convert it to CoreML or convert it to TensorFlow Lite. So that's the first question, right? And the second one was, so that's the biggest deal, right? Because what we want to do, a lot of the cloud providers, a lot of the growth in this is to get those models to be accurate, but yet compress them. Because before they were used a lot for institutions, they were never meant to be mobile. So now we're talking about like, let's get this data mobile instead of hosting on the endpoint. Let's compress that data. And there's a lot of data in those models that aren't usable or useful. So let's extract all those data layers and then just give them exactly what they want. And that's what CreateML is doing. That's what Google Platform's doing with a few of those models. And then what SageMaker is doing with some of the optimization with when you train that model as well. So it's in there. It's in there, yeah. And it depends on, not necessarily for mobile, but it'll be a different terminology they'll use. But the idea is to take these really large, accurate models and be able to compress them down so they're usable on a mobile device. Yeah. And there's a certain point where accuracy with size, and typically that's what it is. More accurate the model, the bigger the size.
Is there an AWS service that's, like maybe if we use Cognito for authentication, that can detect the specific kind of device and iOS, and then consequently, based on that, maybe we can route the traffic to either use Edge, for the use case, or route it to the API based on, more data device, et cetera. So kind of have a hybrid between the second and third options that you just shared with us.
Yeah, so I think the question was, like, can we do a combination of, or like a hybrid, like whether we do it on a device. So like if you're on an iOS device and it needs to decide, like, if it's some feature that it can't do it on the device, yes, you can do a combination of both. Like, say you want to do edge compute on certain features that are doable on the device, right? And then if it can't do it, send it to an application service. So a good example of it would be like, let's say I have a model on the edge that's for my family, right? And it knows all of our faces perfectly. But then I want to know and identify a picture of me or my family member with a celebrity. So it's a really good example, right? Because you could say, okay, there's more than one person. It doesn't identify the family. Then at that point, you can say, okay, great, I identified this person as family, but there's another person standing there. Let's go find out what celebrity it is. So then we can call the celebrity API and then attach that as well. So we kind of use a combination of API call versus the edge model that's on the device. Does that answer the question? Or?
Not really. I think the exact use case would be more of like, we have the same feature, let's say again using the face recognition for your family.
Mm-hmm.
And one user accesses it on the latest iOS, so we can leverage the edge computing. Another user is accessing with a dated iOS, and it might not have the edge computing capability.
Yes.
So is there an AWS service that can maybe help us to, register the device and the iOS, and then consequently on the app, we can route that request to either stay local or to route it to the API if it doesn't have that edge computing ability based on, obviously it could be wrong, but based on, the device and the iOS and the OS.
Right. So the question is, like, based on the device type, whether it's going to use the local and try to do the prediction on the device, or go to the cloud and make the prediction. Yeah. Yes. Yes. Yeah. So there's not technically a service that does the prediction, like tells you, okay, this is an iOS device, and goes and makes that call. But as the mobile developer, that's what we would do. We would say, okay, if this is an Android and it's the KitKat version or lower, then always make the API call. Never, it's not on there. So, or a simple, like, is the model on the device? Nope. Make the API call. And technically that model would be the same thing, kind of a smaller model, but it's hosted in the cloud, and then that's capable through SageMaker. So that's a really good example where a combination, like a hybrid, where the device, but you do the prediction yourself. It's just, it's easier, right? You just launch the app, and if the model's not there, and on startup, that's where you can start collecting analytics. On startup, as the device, loads the app, and it's like, whoop, if it's this, don't put the model on the device, or don't download the model, or don't use it. It's not capable of it. And then it does an API call. And then it's a setting in the user preference or whatever as for the life of that app, and it makes an API call. And then you start collecting that information. So then back to collecting analytics, you'll collect analytics from those devices and figure out 80% of my users are, making API calls because they have older devices or older operating systems, however you want to play it. So yeah, you can use a combination, host it behind the API. And again, it doesn't have to be a massive model hosted behind SageMaker. It could be something small, but yet now you're adapting to a lot of those 90 percentile of all the Android users in the different countries, different styles, different devices, and different latency. Because sometimes you might want to do a little bit of both. Because take advantage of the device when you can. Like this is the iPhone XS Max, and this is capable of a lot more than the Samsungs, the older Samsungs. So there's a big difference. Yeah. Yeah. Okay. So this one we're still in part 3. So we've host the model behind the API. And we deploy it to prediction endpoint, and then we invoke the HTTP endpoint from our device. Just like we did with the recognition, the celebrity, all we did was send an object to it, and then you decide what information you want to send to it to make that prediction, whether it's a piece of text or whatever. So, you could have images like remember talk about the custom logo and the trademark? We could have a custom model that has all these trademarks in there and send a picture of a trademark, and then, what business is it? It could be labeled as a business, like, the BMW logo or the AWS logo, and take a picture of it. What business belongs to this logo? There's actually a fun game out there, like the logo game. Have anybody ever played it? And you get in groups and you just look at the card, and it's a picture of, the AWS, and you're like, well, that wouldn't be fair because it's AWS, but, just like a car logo, and you'd be able to identify what business it is. So it's all about branding. So that's the same thing. So you have this model, put on in the cloud, and then invoke it with the HTTP endpoint. So again, some of the cases like best when devices are not powerful enough for local inference. In your use case you're talking about, models can't be easily deployed to devices for some reason. Maybe they're offline. Additional cloud-based data is required for prediction. Prediction activity must be centralized. So, and then device support HTTP and network is available and reliable. So one of those things where we're always online, it seems like, but when we want to make those calls and those predictions, and we could even do some kind of even a hybrid approach where we have the model, maybe a model has a little bit, is really accurate, but it only does a couple use cases, right, on the device itself. And then if they want more information, if they're online, you can go and send that information to another model online and get more detail. So you kind of a double approach thing. So have this nice model that does a quick analysis and like, okay, great. And then if it's not something that it found, like if it didn't identify as an object of a kitchen, then don't even send it to this API call. And if it did, then send it and get more details. So you could do it that way as well. So sort of that hybrid approach there where you want to get more information. Okay. Now, utilizing platform APIs. This is the number 4. So remember, 1 was, what was 1? Calling an application service, right? I was testing you, but I also forgot. Testing application service. 2 was build the model, host it on the device. That's the edge machine learning. Number 3 was build the model in the cloud and then keep it in the cloud and host it in an endpoint, HTTP endpoint, or a combination of both if you want to do that. 4 is utilize the platform APIs. And this is what we're going to talk about after lunch, using the speech and all the different face. I'll show you some demos of what's available with like iOS and Android with the facial recognition and face detection. A lot of those pieces are in there. So use the framework that Apple performs face and face landmark detection, text detection, barcode recognition, image recognition. So there's a lot of things that you can do on the device and take advantage of, like just flat out like, is this a person? I don't need to send this to recognition. I don't need to send this to a custom model. This is where we're talking about like have a custom model to say this is a person. All the APIs do that for you. It tells me who this person is, and it put landmarks in a square box, and I can just say, just send this face to recognition. Just send this face to somewhere else. And it's a nice small feature base, and you're only sending that picture of the faces. Or like, how many faces are in this image? And then all those built-in APIs will do that for you. So take advantage of that when you can, and then use that, and then send the information in the cloud when you need to. So the idea is like take advantage of all this stuff, like natural language framework is very powerful. You could do things like identification, tokenization. It was where you take those like a paragraph and you break it out into words, and then it can analyze those words. So if I say like I work at Amazon Web Services and I work in Seattle, Washington, it'll tokenize that and then figure out Amazon Web Services together. Bam, capitalize A, capitalize W, capitalize S, and then put it together as a brand. It knows that's an object. Instead of like services, is service should be capitalized? Yes, in this case it will be. So that's adding the smarts to it. So like when you do a chat app or something, you can add this easily in there. You're using machine learning, but you're just taking advantage of the framework that's available on the device itself. So you're talking into it, and then it identifies parts of speech, tagging, name entity recognition. So we're talking about like working constantly listening on the device. And then anybody have the AirPods? The AirPods have the always listening feature enabled. You can enable that feature. So basically you could just be, you're an interface directly to your phone at all times, and you can just tell it to do anything you want, and it's just looking for keywords. So you do the same thing with build your app and just be constantly listening with that framework and listening for the tokenized words like Amazon Web Services. If I say it in that order, it knows and it'll pull up information for that. So very powerful things that you can add utilizing just the APIs. And that could be vision, speech, text, whatever it might be. Those are the three main pieces. And again, it's already being used by the operating systems already, where the text ahead, whatever, any kind of prediction that they're doing. Does that make sense? And then you're not being charged for this because you're using what's available. And again, it's limited. So some of the natural language framework might be only available in NuGet or higher for Android, which means that's 50 to 60% of your user base. So then you kind of look at it and figure out, okay, do you want to do it? In a lot of cases, the speech recognition pieces, the natural language, you don't want to build yourself unless you're doing specific, speech analysis. So recap. 1, call managed application services like transcribe or translate or poly or recognition. If it works great for you, call it, and then you don't have to have any machine learning. You don't have to train a model, and you just call those simple APIs. And they're fast enough, like at AWS, you can call the recognition piece. And in that case, remember the picture I took, and was it like 7 or 8 celebrities it recognized? It took a little bit longer, but I think with one face, it'll just go back and really fast. But it analyzed that photo and then was able to scan the database and then bring it back within, a few seconds. So it's pretty fast to be able to recognize certain things, and then you don't have to build out your model. And then 2 and 3 involve building and training in the cloud using SageMaker and either deploying it to your device. This is where I'd like to see number 2, a big improvement, like we've seen with like deep lens and some other features and other layers on top of the cloud. And we'll see hopefully some more progress with that, where I'll be able, like next year I'll come out and be like, all right, here, start taking pictures, send this to S3. S3 triggers this framework or this service we have, and then everything's beautiful. And then we have the scripts we want this format, and deploy it to my device. And then we'll have that whole life cycle there as well. And then utilize the platform APIs. More and more will be available to you on those devices as the devices get newer. And again, the disadvantage to that would be older devices. So I'm going to talk about a little bit about building and training and just high level kind of what SageMaker offers. Now, there's so many ways to train a model. You can use EC2 instance with a GPU, with a big fat GPU, throw all your data on the S3, and I can pull the data and then just do the framework. But what's nice about SageMaker is end-to-end machine learning platform. So it's put all those pieces together, taking customer feedback and says, wait, I don't want to have all these pieces built. I want to have them all done for me. And then I want to only pay for what I use. So end-to-end machine learning platform, zero setup, flexible model training, and then pay by the second. So again, these are all packaged together with like TensorFlow and MXNet ready to go. And then you just start, it says, where's your data? And then how fast do you want to do it? And then how many compute instances do you want to start up? And it does the rest. So it's kind of like what we've done in the past with like auto scaling, where it just says, okay, how many instances do you want to start up? And then it'll just automatically scale. So you could just do this in 5 minutes, or pay a little bit less and have it done in 25 minutes if you wanted to. And it has all those pieces together. So that's Amazon SageMaker. Now, the drawback for mobile developers, if we're not machine learning folks, which I'm not, is there's still a lot of notebooks you'll hear like Anaconda, you'll hear about Python, you'll hear about notebooks, and these are the current way that we develop and train models in the cloud. So notebook instance, and then you create these scripts and these algorithms, and then the training service, and then hosting the service. So that's kind of the basis of SageMaker, putting all those together. And then you can save that environment. So when you train the model, you can go in and retrain it and start up that environment again and train with more objects. So typically what you do is like 80-20 scenarios. So you have 80% of those images are for training, 20% of those would be for testing. So they haven't been tested on these 20% of images, and then you test that model and start throwing information in. And then all that's done on SageMaker, so you could test that model, see what the accuracy rate is. Yeah?
Does SageMaker have the ability to deploy models on mobile devices? And does it have that built in, or is that something you do separately?
Yeah, so the question was, does SageMaker offer the ability to deploy these models that are trained into a mobile device? Not at this moment. Yes, I mean, a roundabout way, yes, you can extract or export the model, and then you convert it into that format. But ideally, that would be the next case, or we could have someone who built it, and really just like, okay, I go through this whole process, I built this model, extract it from S3, and then convert it to something. And all it is just a script, like all these tools that are available in the script, and put in there. And then compress it. You know, we got to worry about the compression piece. So that's where we're going to tie into that level 2, where we're going to see a lot easier to custom make our models and then deploy them to the cloud using SageMaker. And hopefully it'll be through SageMaker. So the real use cases of machine learning in action on mobile and IoT. So we talked about the security cameras. We talked about the farmers taking advantage of like the edge compute, where they put the model on the device and they're testing like for diseased trees. There's a few apps on the App Store right now that tells us like what type of tree it is. If you take pictures of the trunk or you take pictures of the branches, it'll tell you what type, if it's a cypress or if it's a eucalyptus. We don't have many eucalyptus in Seattle, and I love eucalyptus here. It'll tell you what type of tree that is. And there's other examples. Anybody else see really good examples of machine learning on the vision side? These are the obvious ones, right? But again, a lot of this other stuff, like the text ahead, the tokenization, and the chat applications, and the facial recognition, those are going to be pieces that are going to be more norm for users, and you won't be able to call them out in an app. They'll just be normal use cases as an app when I'm using the application. So does that make sense? Any other questions? Any other things you've seen? I mean, one of the asks I think is the next thing is get that piece where we can train custom models, go outside the application service, and then deploy that model into our devices. And yeah, there's companies out there that do that now, and then we'll be able to hopefully use SageMaker in the future to kind of put those pieces together. And then you've seen with the Deep Lens tool, they do something similar where Deep Lens will take pictures and then automatically feed it back to and build a model, put the model on the device, all kind of simple and seamless to the user. And that would be ideal for us mobile developers to be like, yeah, we got this custom piece, then we can send it over. Yeah. Mm-hmm. Mm-hmm. Yes. So she's talking about the algorithms that are there, like, you know, the frameworks, the TensorFlow and MXNet. And yes, you could actually also bring your own image there. So you only your Docker image, and then Docker could have another framework like Turi Create, and you can bring Turi Create in there, or you create your own and then run in there. So really all it is a bunch of notebooks and a bunch of scripts and using the frameworks. And if you have that framework and scripts that you want to run that framework, then just put it into SageMaker. So they have the default ones with the TensorFlow, they have MXNet, and they have certain algorithms that are just unique, like XGBoost and a lot of the other scenarios that they offer. But if you want custom ones, or if you want to bring in your own TensorFlow, you can do that as well through like a notebook or through one of the Dockers. Yeah, or Docker containers. Yeah. Any other questions there? I think I showed all the demos that we had on there. Let me just quick look and see if there's any questions online. And Adrian, there's no questions. Okay. So we showed the real-time celebrity recognition. We showed the demo of the real-time prediction. Let me talk about this real quick. I'll show you before I do this. We have a few minutes, right? What time is it? Oh, I don't watch. Okay. So here, can you guys see that screen? Okay. I want to show you a couple of the face pieces of using the local API. This is using the facial recognition and detection on Apple. So if I take a picture and then use it and then process. So again, there's a bunch of clicks, but you think about the AR thing is going to come into play because AR can just do that really quick because it's on the device itself. So this is using just the regular facial recognition. So, and it's mapping the face and the eye. But this, when you see the box and you're taking pictures, that's what it's doing, but it's adding, obviously I added a little bit more to it. But this is, I can't go out of this line. The yellow things are just mappings of the face. And so you've seen a lot of the augmented reality features out there, like I think Warby Parker does the glasses, what the glasses would look like on that person. So it's using that because it knows exactly the center, it knows the shape of my eyeballs, it knows my eyebrows, and now we also have tongue detection, right? Which is really the best thing in the world, right? Tongue detection. But as I move, it would actually move with me, those lines. So you can see the advantage of this where if you have anything augmented reality or you want to see maybe you're augmenting a facial feature, like a nose job, or, I want to get rid of my bags, or I want to get rid of my bald hair, or what does I look like with hair, so it knows the exact shape of my head. And again, this is just a simple API call for the face recognition and detection using the local framework from the device. And then there is one more, I think, is a face. So this one is real time. So this is kind of a mix between what I just showed you with those lines. See how it's moving really fast? This is where we could do like the blur out. On video, this is really tough, like chroma. The video guys know chroma screen and all that. But this is the real time where you could actually go in, and it's tough with moving objects. They always say when you're doing a video and you have something to hide, make sure it's not moving because then the editors have to go in and constantly follow like this. But there's a couple apps out there that I could blur my face just perfectly, keep everything else in sync, and just blur where those green lines are. Just take that face and blur it real time. But then I could trick it and go like that. So they saw the face. But that's what they're using in those real-time detections and videos, and they're going in trying to wipe out faces. And you'll see it like in Google Maps and all that. You'll see those faces go by, and they identify it as a face, and they just simply blur it out as it goes through. But this is a good example of, you can see where I'm using the API, and it's tracking the features of my face. And you can take advantage of just the eyebrow ones. You can take, again, the pupils. And I don't know if you see the lines on my eyeballs when they look up and down. It knows the direction. So now we're talking about eye gazing. Anybody use eye gazing? I have a boy, he's 12, he doesn't talk, and he can't do eye gazing because his eyes just are a little wonky. But the idea is there's a lot of accessibility features in this where we could take advantage of, I know I'm looking up, I'm looking down, are his eyes closed, are his eyes open? All those things are capable with just a simple API and just taking advantage of these pieces. Or if I want to put lipstick on a pig, I could put lipstick on using just the drawings of those lines on there and then extract that information. So that's an example of kind of a combination between using the built-in APIs and a little bit of AR where you can kind of transfer all that in there. There's apps making a ton of money that just put on, a face. They'll take that face and they'll put on a mask. You've seen it on Instagram, Snapchat, the vomiting rainbow. All of that starts from here. So it's easy. All you need to do is just have an image and put on there. Stickers, those message stickers, those things are making a ton of money, just like creating a bunch of stickers and throwing a Santa hat on the guy. And then as you're moving, the hat follows you, which is exactly what we just did. And all it is using that information. So I could put a smiley face on my eyeballs really easy. Just take those two images, and then I know the markings. And as the markings go across, I'm just popping that eyeball on there, and I'm done. And I create an app, and I make a ton of money on advertising or something. So So they're making it really easy for us mobile developers to create, enhance these features, and do some really cool stuff. And again, having that facial thing, it's a starting point for what we are capable of and doing the markings on custom models or whatever it might be. Any questions about that before we break for some lunch? And then 1 o'clock we're going to do hands-on, and we're going to build the speech translation app and talk about end-to-end and how that works just with permissions and simple use cases. Yeah. Is there a possible? Yes. Yeah. Once we end this session, I'll put up and you can take a look at it. Yeah. All right. Thanks, everyone.